Today I am going to discuss about Maxima and Minima. This is my first lecture. We have learned Maxima and Minima in class 12. Let's take a function y equals to f of x. F of x is the function of x. X is the independent variable and y is the dependent variable. To find the maxima and minima, we have to follow some steps. These steps are learned by us in class 12. Okay, the first step, at first we have to find dy by dx, the first derivative of the function. Then first derivative of the function is equals to 0. We have to take it to find the stationary point. Stationary point. What is stationary point? Now this is the important question. Stationary point is the point where the maximum and minimum value is exist. Maximum and minimum value is exist of this function. Okay, that means we can say that stationary point is the point where the maximum and minima we can find. In this point, at this point we can find the maximum and minima. Okay, now after doing these two processes, these two steps, then we have to find double derivative of this function at let's take the stationary point is x equals to a. This is x equals to a. At x equals to a, we have to find the double derivative. If the double derivative is greater than 0, then we can say this: there the minima is exist. Okay, if double derivative of y at point x equals to a is less than 0, then we can say that will be the maxima. We have learned this in class 12. We have all learned this in higher secondary level. Okay, now the question is why we do the our main concept is here, why we do first derivative, that means del y by dx, and why we do double derivative. Here the two questions are arising. That means dy by dx, first derivative of the function, and second derivative of the function. Why we do? We know that dy and dx, dy by dx represents slope of the function. To find the maximum minima, if we do dy by dx equals to 0, that means stationary point. To find the stationary point, dy wait dy by dx equals to 0, that means there at the point the slope is 0. Yes, let's take an example. If this is a function, if this is the function where, let's take, this is a point, okay, here we can say that this is the tangent and this is the tangent we can draw, and here the slope is 0. Here dy by dx equals to 0. That means this is a stationary point. That means it is a stationary point. Okay. And here also a slope is 0. Okay. Now let's just considering this like this case. Okay, only this case x equals to 0. Dy by dx equals to 0. That's represent the slope is 0 at this point. Second, from this we can get the stationary point. The stationary point. Okay. By getting this stationary point, we will do the double derivative. Why we do the double derivative of the function? Why you do? Double derivative is used to find the concavity. Double derivative is used to find concavity. Concavity. Okay. Concavity of the graph. What is meant by concavity? In this lecture, we have taken we take the concavity is the nature of the graph. Okay, concavity means that we know that the convex and concave. If double derivative is greater than 0, the first uh, case we are considering here. First case, this is the first case of the minima double derivatives. Minimum and maximum is the second case. Okay, the first case we are considering here, double derivative of the function is greater than 0. That's represent the graph of this point is the graph of this point is concave up. That means concave up. This point concave up. That means this is concave, sorry, concave up. Okay, and second case is if we do a double derivative of the function and it is the less than 0, then we can say that this will be concave down. The graph's nature will be concave down. That means there is concave down. So it will be minima and that will be maxima here. Okay, this is the reason we do the first derivative of the function and second derivative of the function. Now what about if we take two variable function? How we will find the maxima and minima? Okay, see this, I will show you. Let's take a function which is z equals to f of x and y. That means x and y are the independent variables and z is the dependent variable. Here we have to find the maxima and minima. We have to follow some steps. First step is at first similar as the previous one. We have to take the first derivative of z with respect to y, with respect to x, sorry, with respect to x, and second is del z by del y. That means this is the first derivative with respect to y. Then we have to do del z by del x equals to 0 and del z del y equals to 0. By this we can get the value of x and y. Let's take a and b. Say I am considering it. Okay. Now the third process is we have to find the double derivative. Okay. At first the double derivative of z with respect to x, and we have to find the double derivative of y, a double derivative of z with respect to y, and also we have to find double derivative of z with respect to del x and del y. We have to find this. After getting this, another thing, another equation we have to do, that is del equals to double derivative of z with respect to x and y minus double derivative of z with respect to x into double derivative of z with respect to y. Similar process. Okay. Here at first we have taken a function f of x, and then we have to find the maxima and minimum. We have to do the first derivative of this function, then the first derivative equals to 0 to find the stationary point, and also third step is the double derivative of this function, and this function, if the double derivative at this point will be greater than 0, then it will be the minima, and if double derivative of this at this point is less than 0, that will be the maxima. Here similarly we take a function of two variables x and y, and to find the maxima and minima, first step is the first derivative. We have to find first derivative of the z with respect to x and the first derivative of the y, first derivative of the z with respect to y. Then we have to uh, create these equations to get the points. That's meant to points means x comma y equals to a comma b. Okay. And third step is we have to find the double derivative of z with respect to x and y, and also x and y. We have to find these three things. After that, now this equation is much more important. Here three cases are present. Case 1, first case is if the value of del is greater than 0, then the point will be saddle point. What is meant by saddle point? There is a question. Saddle point is the point where no extremas are present. That means no minima and maxima will be exist. Case 2, if del is less than 0, then it will be stationary point. And if the double derivative with respect to x is greater than 0, then it will be minima. Similarly, as we have done, okay. Case 3, last and final case, if del is greater than 0. No, del is not greater than 0. Del is less than 0, sorry. Del is less than 0. Then there will be also stationary point. The double derivative of the function z with respect to x is less than 0. That means there is maxima. In this way we can find the maxima minima of a function with two variables. A function with two variables. That is all about the maxima minima. Thank you so much for staying with me. Love you all.